Hey guys, and welcome back to another video. For this video, I will be going over the 3-point problems for Math Kangaroo 2012 in the USA for levels 3 and 4. So let's get started. Number 1. Basil wants to write the word mathematics on a sheet of paper. He wants to color different letters different colors, and the same letters the same color. How many colors will he need? So, in mathematics, that you have an M-A-T-H-E. They're all different letters, then you get another M. So we only want one of them for one color, so we can just take out this one. Then you have another A and another T. But you don't have an I, C, or S, so we don't have to cross any of those out. Now we count 1, 2, 3, 4, 5, 6, and 7, and 8. So you will need B 8 colors because there are 8 letters that haven't been crossed out yet. Number 2. In 4 of the 5 pictures below, the white area is equal to the gray area. In which pictures are the white area and the gray area different? So let's start with A. So this figure matches this figure and the colors are also different. So that means this right now, if we were to pretend that this part over here does not exist, the ratio of how much of each color is there would be equal. So this matches this and this matches this, meaning A has everything matching with equal ratios of color also, not just figures. So that means A is not our answer. Now for B, same thing. This matches this and this matches this. So can't be B. Same thing for C. This matches this, which matches this, and which matches this. So they each have 2 of that figure. So each color has 2 of it. So that means it's still equal. And this also equals. And this also equals. So not C. Now D here is a different case. D has the figures matching, but the colors are the same. As I mentioned when we were doing A, the colors have to be different. So everything in figures are matching, but the colors have to be different for each figure, but they're the same. Gray, gray, white, white, meaning that it just increases the ratio of one color, but does not make it equal, meaning that D is our answer because it has a different area of white and a different area of gray. Now just to check, E, this is equal and this is equal. Now, on to number 3. Father hangs the laundry outside on a clothesline. He wants to use as few pins as possible. For 3 towels, he needs 4 pins as shown. How many pins does he need for 9 towels? So, we've done this problem before. It was in the level 1 and 2 video for 2012, but this time they made it a 3-point problem because if you're a level 3 and 4, it would have been easier for to do if rather than if you were a level 1 and 2 person. That's why it's made a 3-point problem and not, I think it was a 4-point problem or 5-point problem. But let's see. So for 3, he needs 4. How much does he need for 2? So we can cancel this out, meaning that this pin also gets canceled out. For 2, he would need 3 of them. So we know that 4 minus 3 equals 1. And just as we double checked here, 3 pins minus 2 towels also equals 1. So using the same logic, we know that question mark, which is the number of pins, minus 9 has to equal 1. So the way to do this is question mark is a variable here. So remember in inverse operations, as I taught you in our last session 8 of variables, inverse operations, meaning this goes to here and you add. So question mark equals 9 plus 1. Finally, question mark equals 10. So he will need 10 pins for 9 towels. On to number 4. Iljo colors the squares A2, B1, B2, B3, B4, C3, D3, and D4, and D4 gray. Which coloring does he get? So let's color it on here. So A, just to make it less confusing, I'll change the color to gray. So we start A and then 2. So they match up here. This is colored. Now B and then 1. So B and 1 match up here. B and 2. They match up here. B and 3 match up here. And B and 4 match up here. C and 3 match up here. D and 3 match up here. And D and 4 match up here. So when you match all the figures to this, you will see that the correct answer for number 4 is C. On to number 5. 13 children are playing hide and seek, and one of them is the seeker, and the others hide. After a while, 9 children have been found. How many children are still hiding? This was also in the level 1 and 2 level 1 and 2 for this. So a lot of them will be similar, but the harder you get, like when you reach the level 5 ones, they will be different because the level 5, which is the hardest questions for this one, cannot be done for level 1 and 2 because that would be too hard for the people taking that test. Unless you're very smart, which I think all of you guys are. So, if we have 13 children playing hide and seek and one of them is a seeker, that already means that he cannot be hiding because he has to find them. So, 13 minus 1, you get 12. Now, 9 children have been found, meaning that they're not hiding anymore. So, 12 minus 9, you get 3. So that means 3 children are still hiding, which means our answer for number 5 is A. Now on to number 6. Mike and Jake were playing darts. Each one threw 3 darts. See the picture. Who won and how many points more than his opponent did he score? So let's see how much did Mike score. So he got a 7, a 35, and a 25. We add. Okay, so 5 plus 5 is 10, plus 7 is 17. 3 plus 2 is 5, plus 1 is 6. So Mike scored 67. Now for Jake, he scored 45, 15, and 3. 45, 15, and 3. So 5 plus 5 is 10, plus 3 is 13. 4 plus 1 is 5, plus 1 is 6. So Jake scored 63. So we know that Mike scored more. By how much more, we can figure that out by subtracting 67 minus 63. You get 7 minus 3 is 4, and then 6 minus 6 is 0. So Mike scored more by 4 points, which is E. Number 7. A regular rectangular pattern on a wall was created by 2 kinds of tiles, gray and striped. Some have fallen off the wall. See the picture. How many gray tiles have fallen off? So we know that it's alternating color. So after we can fill it in by after stripe would come gray. So after gray would come stripe. So for the stripe ones, I'm just going to do that. Now after stripe comes gray. And after gray comes stripe. Now, after stripe comes gray. After gray comes stripe. After stripe comes gray. After gray comes stripe. And after stripe comes gray. Now once again, after stripe comes gray. After gray comes stripe. After stripe comes gray. After gray comes stripe. After stripe comes gray. And after gray comes stripe. Okay, my mouth is very dry after saying all of that. Let's see. How many grays are there? So that have fallen off. So we have to count all these gray blobs. 1, 2, 3, 4, 5, 6, 7, and 8. So that means B, 8 gray tiles have fallen off. the last 3-point question. The year 2012 is a leap year, which means there are 29 days in February. Today, on March 15th, 2012, my grandfather's ducklings are 20 days old. When did they hatch from their eggs? So, let's subtract 15 days so we can get to March 1st. So, since they're 20 days old, we can subtract 15 from them, and we get 5. So now we know that there are 29 days in February on this 2012, which is a leap year. So from 29, since we've now reached the end of February and like the beginning of March, we can subtract the 5 remaining from this to get 24. So this means that it's going to be on February 24th, which is D. So that is all for the 3-point problems. I hope this will come in handy and you understood all my ways of solving. Thank you for watching. Like, subscribe, hit the notification button, and please keep on watching. Bye.